continuing on with our lesson, so the final way to tell is from a t-chart or from a table of values. So from a t-chart, a relationship is linear if the first differences, and we'll have to talk about what first differences are, um, the pattern in the x and y column is the same. And I'm just going to get rid of that, exactly the same. So when we're talking about the word differences in math, remember difference means to subtract. So we're going to end up subtracting here, and I'll just put the word subtract for you so that you can remember that that's what that means. So differences, so it looks like we're going to be subtracting something. Now the reason we call it first differences is we're only going to subtract once, okay, in a column. Okay, so instead of taking the column, subtracting, and then taking those numbers and subtracting, that would be second. We could do third or fourth. But for linear and nonlinear, we only have to do the columns one time. So both the pattern and the x and y have to be exactly the same. So what that means is when we go and actually take, and I'm going to switch, oh no, I think maybe I'll keep doing it with the mouse. So when I look at my x column, first of all, when I say exactly the same, we're looking at the distance between the numbers. So I always start at the bottom because when I'm subtracting, because then I know that I'm going to have it right each time. So 3 minus 2 we know is equal to 1, and we can go 2 minus 1 and 1 minus 0. Okay, so those are exactly the same here. And we're going to try now over here, and again we're going to start at the bottom and work our way up. And later on you'll see why we're starting at the bottom. So just get in the habit of doing at the bottom, and then you'll have the next part when we come to that lesson. Oh, well, wouldn't you know, it's not 8 minus 2. The answer is 2, so it's 8 minus 6 equals 2. And again, if I do 6 minus 4, that equals 2. And the distance from 4 minus 2 is 2. Okay, so you can see that the x column's going up by ones, the y column's going up by twos. So that means that my x's are going up the exact same amount and my y's are going up their exact same amount. The 1 and 2 obviously isn't the same, but as long as in each column they are the same. So this tells me that this relationship is linear. Now, you're saying, I don't know if I can take your word for that, Mrs. Broadhagen. Well, I'm going to bring up the graphing calculator because we also know that there's some other special features on it. Now, I know what the equation of this is, and I'll prove it to you when we go to show you the table of values on the graphing calculator. So if I go to enter my equation, I know it's this. When I graph it, this is a straight line. We all agree at that. But I don't have the exact one for this equation. All right, so now if I go to my table of values, you can see here, you might have to look really closely, hopefully the resolution's good. So it says when x is 0, y is 2. When x is 1, y is 4. When x is 3, y is 6. And when x is 3, y is 8. And you can see those are the exact same points from here. So if I actually graph those points, I would end up with this relationship. Okay, so actually if I took those points and graphed them, I would get that line you saw in the graphing calculator. So that means that this is linear. I'm going to do it the same kind of color, so linear. And I'll make that larger too, because that's probably hard to see. Probably still large, too large. There we go. Linear. So now let's look at question number 2. The same thing we're going to go here is we're going to start at the bottom. 3 minus 2 is 1. 2 minus 1 is 1. And 1 minus 0 is 1. So far, so good. All of those are 1s. Now, if we go over here, 16 minus 8 is 8. 8 minus 4 is 4. Already, they're not the same. And 4 take away 2 is 2. Okay, so these are different. So because those numbers are different, it's nonlinear. That doesn't mean to say that it doesn't have a pattern, because it does have a pattern: 2, 4, 8, 16. And can you guess what the next one should be? Probably 32 if it follows the same pattern. So it's not that it just it has a pattern. The first differences when I subtract have to be the same. So these numbers are different. Okay, and because those numbers are different, what we can say then is therefore nonlinear. So based on that, we can say nonlinear. All right, so let's go to another question. Okay, question number 3, same kind of process. This time we'll use red. So 3 minus 2, 1, 2 minus 1, 1, 1 minus 0, 1. Looking good so far. And then what happens here? 2 minus 2 is 0, 0, 0. Okay, so remember 0 is a number. So we can have 0 as an answer when we subtract. So because this column has the same number and this column has the same number, we can then say for sure that this is linear. Okay, and I'm going to make that red so it matches. So linear. Oop, that's a funny linear word. And cap locks on. All right, so last question. Let's start here. So we have 8 minus 4 is 4. 4 minus 2 is 2. 2 minus 0 is 2. Now our problem is here, and these ones are going up by 1. Now based on this, these numbers are the same. These ones are different. Therefore, it's non-linear. Okay? Now, if these x's had been different and the y's had been different, then I couldn't really say for sure whether it's linear or non-linear, because remember, we can choose what other values we want for x. So I could have chosen, for instance, this last one, I could have chosen the numbers 0, 2, and 3, and I still would have had 2's each time. So I would have had that the y's would be the same, but the x's would be different. So you can't always go by if two of them are different. Okay, and you're saying, yeah, but you know what? If I look back up here, what you said if the first difference is the pattern in the x and y column is exactly the same. So if they are exactly the same numbers in each column, then it's linear. But if one is the same, the y's, but the x's are different, you can't say that it is linear. Okay, so that's a little bit confusing. It's kind of like those exception to the rule kind of questions. And the same is true if I went to graph those points, it wouldn't be a straight line. So it is possible, as I said, that with these exception to the rule, so this is an exception to the rule, so these are the same. And these ones are different. Yes, that's most writing that you're seeing there, different. Okay, so a lot of the questions you're going to have, you're not going to see this exception kind of rule here. And in most cases on a test or when you're being assessed, what will happen is they will not have this kind of where it could be one or the other. It'll either be linear or nonlinear based on what the numbers are, the first differences in the x and the numbers in first differences in the y. So if you end up with your x's being different or your y's being different for test purposes in grade 9, it will be that it's nonlinear if they are different. All right, so tomorrow you get to do some mathematical pleasure.